lesson 2.4, we are going to talk about the exponent of an exponent. This is a very common property, especially when we get to algebra and deal with letters and variables. For the moment, let's first analyze what happens behind the scenes of math, and then we build an equation. So, for this, we need to remember that an exponent is always going to tell us how many times we multiply the base. So, if we have the base of 3 to the power of 2, which this is the case this time, 3 to the power of 2 is the base, and the exponent is a 4. So we need to multiply that 3 to the power of 2 4 times. Let's do that. 3 to the power of 2, 3 to the power of 2, 3 to the power of 2, and one more 3 to the power of 2. That's 4 of them. But we still have exponents. We want to break this down as much as possible. So we still have 3 to the power of 2, so that means we need to multiply that 3 2 times. Let's do it. 3 times 3. Now, we still have 3 more of this, so we have to keep going until we run out of them, until we finish them. This is the first one, 3 times 3. Then the next one, 3 times 3. And the last one, 3 times 3. And now we have broken this all into this big multiplication that we can now reduce into just one base with one exponent. For that, remember, all of this are just 3's multiplying. It means the bases just turn into a 3. We can copy them into one base of 3. And to figure out the exponent, we just count how many 3's we have, which in this case is 8. So the exponent is 8. So all this exponent of an exponent turned into 3 to the power of 8. But as usual, we want to figure out what's the relationship between the original exponents, which are 2 and 4, and the new exponent, which is 8. And in this case, it's a multiplication. So because 2 to the power of 4 is 8. So when we have a multiplication of exponents, when we have an exponent raised to another exponent, we multiply them. So to get 8 in this case. One more time, this is a math property, meaning no matter where we do it, we always get the same answer. But let's write now our equation that works every single time as we like to do it. This is a to the power of m to the power of n. So what we do is we take the base, we copy it, the base will not have any changes, and then we multiply the exponents. M multiplied times n. We know we have to put this into practice, so let's do the first one, a to the power of 3 raised to the power of 7. So the 8 is the base, we simply copy that base, so that's just an 8. And then we multiply 3, which is the first exponent, times 7, which is the second exponent. So this is a to the power of 3 times 7, which is a to the power of 21. Let's do one more for practice, -4 to the power of a to the power of 2. Yes, negative numbers can also have exponents. We just have to make sure that in this case, the base is a -4. So we need to copy the 4 with the negative. The negative is part of that exponent. And then we start raising. So we have an exponent of 8 multiplied, and then an exponent of 2 multiplied. So this turns into -4 to the power of 8 times 2, which is -4 to the power of 16. And of course, it can get a bit harder. We can have this big parenthesis with so many exponents, but still the rule is the same. We could even have 1,000 exponents, 432 exponents, 2 exponents. As long as they are raised one to another, we just multiply them together. So let's do it on this example. Well, first we know the base is a 13, so let's simply copy that base of 13. And then we start multiplying the exponent. That initial 13 doesn't really have an exponent written. Remember, this is equal to 1. So we start by copying the 1. Then we move on to the 5. So 1 times 5, multiplied times 2, and multiplied times 10. Finally, what do we have? 13 to the 1 times 5, which is 5, times 2, which is 10, times 10, which is 100, 13 to the power of 100. And this is why we use exponents, because 13 to the power of 100 is a really, really big number, so we can just write it as 13 to the power of 100. For more math lessons like this one, visit our website, mathusermanual.com, or follow us on Instagram at mathusermanual.